have essentially just one section to do, which is linear differential equations. It's a big section. It'll take us all day today to do that. Let's talk a little bit about what's going to happen in the future. All we have after this, and I guess all's not a good word, but we've got one more day. And what I'm going to do during that day, which is Thursday, is that we're going to spend some time just revising for your final. So we can go over homework questions, we can go over topics that weren't very clear. It's pretty much anything you want, right? So Thursday will be that. And I would like to show you, before we get started on this work, I finally found the page I wanted to show you. I'd like to show you a new resource that I've got up, which is to help you for your final. So you should be looking right now at your class's Canvas site, or at least my version of it. And you see up here, practice final exam. Oh. It'll kick in a few seconds. Here we go. This is questions similar to the types of things that you're going to see in your final exam. Your final exam, by the way, is much, much smaller than this, right? So this is overkill. Now, your final exam is going to be a PDF that will appear on the day of the exam, and it will appear in Canvas. So WebAssign will disappear. There won't be anything on WebAssign to do with this final exam. It will be a PDF. The questions will be written down, and you will write all your answers on paper, and you will scan your working, and you will send it in to me on a Canvas shell that I'll have set up. So let's tell you a little bit more about your final exam. We'll go into this more on Thursday, but it's got two distinct, let's make this full. Maybe make it a little bit bigger. There we go. It's got two main sections. Section 1 is going to have 10 multiple choice questions in it. And here are examples of those questions. So you can see kind of what they're like. And you know how I said there's 10, do you see how there's 20 examples here? So that's twice as big as the final exam. And they're 5 points each, so that's what's that add up to? 150 points. And the other 250 are from section 2. And section 2, with the exception of any question that we did numerical stuff on. Remember doing Simpson's rule with 8 strips and trapezoid rule and all that good stuff? That's not going to be in the final. We tested that in your homework, so it's good to go, right? So it'll start with indefinite integrals, and it basically goes all the way through eventually, to differential equations, which is what we're doing right now. But we also have the solutions. So you can see what the answers are. And if I scroll randomly to some point, there we go. Here is the question that's appeared in the top half. Here is the technique for solving it. Here's another one. Oh, remember X subs? Here's an X sub question. So what you're getting here, if I scroll to the end, here is a variable separable differential equation, right? And so on and so forth. So what I've got done here is just a resource. So it's not a piece of homework. It's not something you need to do. It's there if you want it. I would use it if I was a student. I think it'll give you a good insight into how I write questions and the way they're set out. And I want you to think of it as more like what you would have done in a normal class. You know, in a normal class, you would have entered the room and here's your test paper. Well, you're going to enter Zoom because I'll still see you. But instead of me physically handing you a test paper at the beginning, Canvas will be set up so that it will appear right at the start. And you have 3 hours to do it and half an hour at the end to take pictures and turn it into Adobe, use Adobe's scan and turn it into Canvas. Any questions about that before we return back to the work for today,
I
which is...
understand we are printing this off that day.
I wouldn't, you don't need to print it off. If you've not got a printer, it's fine. All you will be doing is writing down the answers to each question on paper and then just doing the usual. Now, if it helps you to print it off, I would print it off, but I wouldn't bother otherwise.
Okay.
You will take more room or less room anyway. You know, some people, the space I've left won't be enough. It's just a kind of, if you separate out questions, it's easier for people not to miss one. But if you put them right next to each other, you could skip one without even knowing it. So that's it. So no, you don't need to. All I need to get from you will be the working. If I don't see working, you're not getting anything. The exception to that is multiple choice. In the multiple choice questions, right, the first 10 questions, little A, B, C, D, E things, all I want from you is A, B, C, D, or E. And the reason for that is there is no partial credit for those. So you either got the right answer or not. So see if you don't know the answer, just guess C and move on. You might get lucky, right? And that's fine. But for section 2, I need to see the working. So if the answer is 42 and all you've written down is 42, I'm giving you 0 points because I could go into Mathematica and put that in and it would tell me it was 42. So I don't need that. I need to see the working. Plus there's partial credit. Say again, Skylar?
Oh, question in the chat.
Oh, could you read it out to me? It's very difficult for me to get chat.
Yeah, so do you want us to show our work on the PDF of the exam, or can we do a separate paper with the work and answers and turn it in with the exam?
Yeah, I do not need the PDF one at all. I just need your working. It would be nice if you could make sure that you numbered the questions so I know which working belonged to which question. But I think that's pretty obvious, wouldn't you? You'd put number 5 and the working for question 5 and then number 6 and it's working. So no, I don't need the PDF. I don't need you to print it out and scan it back to me or anything. All I need is the working. Any other questions? You've got the job of reading them out if there is any, Skylar.
How many questions did you say was going to be on the second section? Sorry.
There are going to be 10 in section 2 as well.
Okay, thank you.
So it's 10 and 10. 10 multiple choice, 5 points each. 10 section 2, 25 points each, roughly. And so partial credit in section 2.
How is the grading going to work? Because I know for originally it was going to be, the midterm was 20%, the final was 30%.
It's still 30.
Still 30? Okay.
Yeah.
Perfect.
Nothing different about it. It'll because you get partial credit, it's very important that you show good working and clear working. So that's about the only restriction I would say. Try and write more than you need rather than less in case you screw up, because then I can see where it went wrong. Right. If there are no more questions, we shall get started with solving linear differential equations. Any others? We are good to go then. So let's get back to this stuff. Okay, here's our first one. It's similar to question 5 in the homework, as most of my questions are. You really have to use homework questions to do these. If I just randomly picked up things and wrote them down, the chances are it wouldn't work. I wouldn't be able to get the solution. So we have to kind of rely on them. Right, this fella here, it's not X and Y anymore. It's R and T, and the R is like the Y and the X is like the T. So just think of it like that and you'll be fine. I'm looking at this and the first thing I noticed is that the derivative has some expressions next to it. So what I'm going to do is divide each piece by T log T. So this becomes 1 over T log T, R. And this becomes 9T e to the T, all over T log T. Then I'll take this fella. Do a bit of cancelling, not much actually. And we've got that. So basically what we've done here is we've made sure that it is in its standard form. So it's derivative on its own. If you get that bit, the rest kind of follows. So derivative on its own, some function of the variable equals some function of t. Now in this case then, p of t is this guy. And q of t is this guy. And I find it helpful to have this line where you physically write them down. So we're good. Now you get the integrating factor. And it's e to the integral of p of t dt. And there's going to be e the integral of 1 over t log t dt. And that is our first problem. Roughly about half the questions, this integral you can do in your head and just write it down. But in the other half, and this is one of them, this integral, just this bit here, you can't do it in your head. You got to do some process, which means you're probably going to do a U sub or an integration by parts. This particular question is a U sub. And it's not even that clear what the U sub is, but it is a U sub nonetheless. Anybody got an idea of what the right U sub for this integral would be? There's not a lot to choose from. So kind of go with what's there, because there is only there's a few things that are there. So who would you go for? Who's your U sub?
Do natural log of t.
Right. Can we work on the assumption it's the only thing left? Because you can't use t, right? You never use a U sub of just a single variable. Now, let's show you that it actually works. If you differentiate a natural log, you get 1 over t. If you do the crossover, oh, we've already isolated dt. So it's going to be 1 over t u times t du. The t's cancel, and it's, isn't that pretty? And we know how to integrate him. It's a log of u. And then, how about this is a weird answer? It's a log of the log of t. That's a pretty weird looking answer. So over here, it's e to the natural log of the natural log of t. And you should always be thinking, especially at this point and then later on at the end, style points. I can actually rewrite that in a nicer format. Has anybody got any ideas of how I could rewrite this as a nicer version of itself? Do you see that e in that natural log? They're called inverse functions of each other. What that essentially does is that they cancel each other out. So you cover them up, and what's left is what it simplifies to. You see that? And e to a log cancel each other out, and what's left is what it simplifies to. Right? We are 3/4 of the way to being complete. So the final stage is the solution. Now, normally the solution would be this guy. But since they've changed variables on us, it's the same formula. But think of the t as like the x, right? So what do we have? We have 1 over the natural log of t. That's not very nice. The integral of I of t, which is the natural log of t, times q of t, which is this guy, dt, add c. And almost like magic, really. You see that this log cancels out this one, and all you're going to have to integrate it cancels out is that guy. And integrating him is actually very easy. It's 9e to the t plus c. Instead of y equals, it's r equals. Now, style points at the end. I would suggest that that's as good as that one's going to get. So I didn't need to do anything. But there are going to be situations where whatever this is, you can fix it a little bit, or maybe distribute it through and make it nicer. So you should always have at the back of your mind, can I make this look simpler, nicer? And you should if you can. Are we good? Any puzzles, any problems? Can I give that a few seconds?
Okay.
Okay, and this is question 5 overall. There's a lot of different situations happening. So my next question is straight after question 4. Right, when you look at this question, yep, derivative, we're good to go. In this one then, p of x is just the number 3, and q of x is that guy, and that does not look good. I'm kind of worried about how ugly that is, but I'm trusting the math just like we did in this previous question, right? And things should come out nice. Integrating factor. E to the integral of p of x. E to the integral of 3. You couldn't get much nicer than that. You get e to the 3x. Right, you see that's an example of one I didn't need to do anything special, right? Half the time you'll get a nice easy integrating factor, right? The answer you can do dead easy. Other times you don't. And this question had the added advantage that I didn't need to even do any style points. You notice I didn't need to simplify it. It was pretty good as is. So we're right on to the last piece of the puzzle, the solution. So it's 1 over e to the 3x. The integral of e, where did 3 come from? Oh, something's misread. Oh, my mistake. That should say 3. I just copied it down wrong. Right, that's e to the 3x up there. So what do we get? We get e to the 3x times 4, the sine of e to the 3x dx plus c. Oh dear. This integral is horrible. This one is also a U sub. Right? You typically it's going to be U sub or integration by parts. This is another U sub. Which is why I spent as much time as I could on U subs, because we want to be good at them. Looking at this integral here, who would be the natural U sub? Is there anything in here that looks like it could be a U sub?
E to the 3x.
Yeah. Why did you pick that one? It is the right answer. What kind of looked right? Does it just feel right for no other reason?
Yes.
Yeah. But sometimes that's what your brain is doing. You get so used to doing U subs that your brain will tell you what it is without you really sure why you picked it. And it is the correct one. So differentiate with respect to x, and you get, well, the derivative of e to the 3x is e to the 3x times 3. Remember, it's differentiation, Alan. The crossover, and then you isolate the dx. And then I'll go over here and I'll leave the 4 and the e to the 3x, and I'll call that guy, and oops, e to the 3x. So I won't change anything yet. I'll be changing it very shortly. And the 4 and the 3 get me 4/3. They two cancel, and that becomes the sine of u. So do you see it came, oops, that should be a u there. Do you see it came out actually really nicely, didn't it? Now you integrate that, you get negative 4/3 cosine u, which gets you negative 4/3 cosine of e to the 3x. And that means we can now do this guy. We got that. Okay, look for style points. Is there anything that we could do here, or anywhere, I guess, but in particular, anything we could do here that we could rewrite it slightly nicer, just a tiny wee bit, but important nonetheless?
I took the fraction out. I don't know if that's correct though.
I wouldn't say it's wrong, it just doesn't help. Well, maybe it helps a little bit, but not significant. I'm thinking 1 over e to the 3x. Can you think of anything, another way of writing 1 over e to the 3x?
E to the negative 3x?
Yeah. Now, I don't think, it's a bit like taking out the fraction. I don't think it helps much, but it's like maybe a 1% better looking. That's about it. Plus, when you have to put things into WebAssign, it might not take the top one, but it will take this one. So you have to be aware that, you know, you may have done the question correctly, but if you don't do it as, you know, as a style point version, it may not accept it, even though it is correct. I'm moving this a little bit quickly. Are we good with that one? Any questions about it? Okay, good is good. Oops, that one doesn't want to leave. Go away. Now, there are a couple of questions that I'll have to show you what they look like, just so that you know what you're going to be doing. So here is the first. There are two of them actually, so I'm only going to do one. What you should be looking at now is the homework. And this is question 7. Are you seeing the homework? Are we good? Right. So here is the linear differential equation. It might not look like it is the linear differential equation, but here it is. And we are meant to solve it, but not all the way to the end. We just take it to the point where we write the y equals and fill in all the pieces, but don't evaluate it. Right, so you know the bit where you write y equals 1 over ix and the stuff that happens? We're just replacing the ix in all the pieces and then stopping. And it should be one of these. So that would be an example of what a multiple choice question would look like. But instead of having 5 choices and only one of them's right, I would call it A, B, C, D, and E, and you'd pick the right letter. So question 7 is like that. And there's the other one, question 8 is like that. Any preference for which one you would like me to do? Because I'm not going to do both, but I will do one. You want 7 or do you want 8? Come on, I'm giving you a hard question here.
Can we see 8 again? 7.
7 gets the job. Okay, so if you wait just a few moments while I write it down, I'll switch over to the white screen. And here we go. So what you got here is we are going to solve this, but only roughly 2/3 of the way. We'll stop at the 2/3 mark. First thing I'm looking at is it y by dx on its own? No. So I'm going to divide everybody by sine x. So this guy here becomes cosine x over sine x, y. This fella here becomes 3 sine of x squared over sine x. And if you're thinking about it, no, you're not allowed to cancel these. Now, that is p of x then, is cosine x over sine x. And q of x is this ugly guy. So let's find the integrating factor. It's going to be e to the integral of cosine x over sine x dx. I need to integrate cosine x over sine x. I can't do that in my head, so I do it at the side. How am I going to find that guy?
The quotient rule?
If we were differentiating, yes, but we're integrating.
Oh,
U sub?
Correct. So I just need to know which U sub to choose.
Sine x.
You nailed it, sine x. So you differentiate and you get cosine x. Have we done about 100 U subs by now in various places? It feels like we've done 100, doesn't it? And isolate the dx. But that's what essentially, that's what we call experience in mathematics. That if you do lots and lots of examples of something, you gain experience in doing them. And eventually you'll have seen so many different situations that you just kind of know when you look at something that it's a U sub and who the U sub should be. So it's e to the natural log of sine x. Now remember I did it earlier where we had, I think we had log t up here in an earlier question. If you have e to a natural log, because they're inverse functions of each other, don't they essentially cancel out, and what's left is what it simplifies to. So this simplifies to sine x. This question's almost finished. The solution then is this guy, the integral okay. So it's going to be 1 over sine x, the integral of sine x. Q of x was 3 sine x squared dx plus a c. And I almost forgot it. It's 3 sine x squared over sine x. The sines cancel. And we get the integral of 3 sine x squared dx plus c. It's not quite written that way, but that's Webasine's problem, not ours. That's how you would write it, or that's how Webasine kind of wrote it. And the guy that looks like that is D. 1, 2, 3, 4. The fourth dot down. Now, in a multiple choice question, I would say I would give you the 5 choices. I would call them A, B, C, D, and E. And this is what your exam would look like. For a multiple choice, the only thing I would see is 7D. So that means you don't need to show me any working. You can take some shortcuts. If you think, I can go from here to here without the middle line, then do it. For multiple choice, anything that works for you is fair game. Any shortcuts you can come up with, any. Actually, if you don't know the answer, you will guess C. Correct? And if you don't like C, pick any letter of the alphabet that's your favorite letter, as long as it's A to E. And if it's true in the military that if you don't know, when you get aptitude tests, if you don't know the answer, isn't it if you don't know it, you pick C? Is that the scuttlebutt? You're nodding your head like
yes.
That's actually true. It is true, Skylar. So you will pass any aptitude test in the military if you just pick C's.
Oh no, you won't pass, but
It's as
you
good
have,
a
you
letter
have
as
an
any.
answer. You have
You'll
an
have
answer.
Okay. So do the military, pick C or some other letter if you feel you like it.
You might have a rough day ahead of you, but
Okay. I'm glad I was never in the military. Yeah. Although I actually, one of the career choices I did have when I left university with my degrees is I did try and join the military, believe it or not. My duff eye stopped me from doing it. I was going to go into oh God, what was it called? The Education Corps, which is a strange title, but that's what it was called. And I failed the medical because they don't like you if you've got one eye, because if you lose one eye, I'm blind. Whereas if you've got 2 eyes and you lose one eye, it's not as expensive to them. I guess your invalidity is less. Go figure. But I was wanting to do that actually. So moving on, where should we go next? Oh God, yes. I have to do this one because I've done it with my other class and this one caused havoc. So I am warning you right now, this is going to cause pain. Okay. You want to solve it. This is the last one of this bunch. There's two bunches in linear differential equations. The ones we've been doing right now, the solution that you've got is a general solution because they all have plus c. The second half after this one, you're going to also find the plus c. And that's essentially the only difference. So back to this one. Would you agree that this one is not in the right format yet? It doesn't look right. You see that x squared shouldn't be there. So if you divide everybody by x squared, we got that, right? So P of x is 2 over x, and Q of x is this ugly guy. Can you hear background conversation? Because I can. Right. Can you hear it now?
No.
You're good. My wife is talking to her sister. If you've got any in-laws, the worst thing you can ever do is let your wife talk to your sisters. We have a phrase in Scotland that says they could talk the hind leg off a dog. Do you know that phrase?
No.
You get the gist of what it describes. That's totally sexist, isn't it, guys?
I'm sorry, but I might have to use that one, Mr. Robinson.
Oh, do you want to use it?
Yeah.
Yeah, I'm not quite sure what it means. Well, I know what it means. It means she talks a lot, but I'm not quite sure how you talk the hind leg off a dog anyway, but evidently it's physically possible. My dad had some weird sayings. I'm going to have to get these out of my head. My dad would say things which are old sayings, like, do you know a person who's never contented about anything, right? And they're never happy. If they won the lottery, well, it wasn't a rollover week, right? They'd find something negative about everything. My dad had phrases like that. He would say something like, you know, you never see a contented farmer or a one-legged donkey. And I used to think, what the heck does that mean? But evidently farmers are in general very pessimistic people. They're never happy. It rained too much. It didn't rain enough. The sunshine came at the wrong time of the year or something, evidently. Okay, back to this one. We got our P and our Q. We should be able to get our integrating factor. I don't think anything particularly horrible has happened, and I have promised you something horrible is going to happen, so I have to keep my promise. But not yet. This isn't the horrible thing, but this is a little bit of a challenge. I need to make this pretty. And if you think that the answer is 2x, sorry, it's not. Well, you said you could take the e and cancel out the x, and what was left, was the simplified answer. But that 2 is not in the right place. Isn't there a law that says 2 times a log is the same as a log of the thing squared? It's called the third law of logs. Now I can cancel those guys out. And now we have this fella. So the integrating factor isn't 2x, but x squared. Ready for the solution. This is where the ugly happens. And you lot are going to be able to tell me much quicker than they did. Q of x is 23 cos squared x over x squared times an x squared. I'd say the x squared cancelled, and we have now got the horrible bit. We got to integrate this guy. And the question is, how? Well, it tells you, like I did to them, it's not a U sub and it's not an integration by parts. It's a trig identity. And I'll just pull out the 23 so that we can just focus on the guy that we need to worry about, which is cos squared. Does anybody know a different version of cos squared, a trig identity with cos squared in it?
Is it half of 1 plus cosine 2x?
You should have been in my other class today. You nailed it. Now, that's not a very common integral, right? But if I think back to when we did trig, remember we did a section on trig integrals, ones that, especially ones that had trig identities in them. Didn't we have to do a cos squared x or a sine squared x at least once, if not twice? Now that means you only get to see something 2 or 3 times, and then it kind of disappears. You don't see it again. Now in this case, if you pull out the 2, right, the half I should say, you get that. Right, integrate 1, you get that. If you integrate the cosine of 2x, now I have my integration cap on. If you integrate the cosine of 2x, you do get the sine of 2x times something. When you integrate, what's the times something? Come on, let's not fall in the last turtle. We did so well.
1/2.
Yes. If you were differentiating, what would you times something by? 2. You see a difference between differentiation, you times the answer by 2, integration, you times it by 1/2. Also, the sign would have changed if it was differentiation. So we are back over here, and it's 1 over a squared. 23 halves x plus, there we are, 1/2 the sine of 2x plus c. Now that is one downright ugly, horrible mess. I don't think you could make it really, you could do a lot with it to make it pretty, but we should try at least to do something, right? So I might distribute this thing amongst all the terms. So if I did that, I'd get 23 over x squared with this guy plus c over x squared. And then if I distribute the 23, I get 23 over x. I get 23 over 2x squared sine 2x. And then I just have a c over x squared. I'm not saying that is a very good answer because it's ugly, But out of the three choices, this one's a little bit nicer than the other two. And that's about all I could say for it. It's not nice. You agree that is one ugly looking answer. I mean, there's nothing pretty at all about it. Are we good? Now, what's the new guy in town? I'm not going to do it for this question, but you might be told y of pi equals 2. We call them boundary or initial conditions. And if you are given this extra piece of information that the others weren't, isn't that guy's one and only job is to tell you who C is? That's what it does. And so that's going to be the last part. And once we know how to do that, we are finished. We have done every possible version that we're going to deal with, at least, of linear differential equations. So let's do 12. Y dashed equals x plus y, and y of 0 equals 8. Now I'm looking at the format that it needs to be, and although that's quite nice looking, shouldn't that y be over here next to the derivative? So I'm going to subtract y from both sides. Are you comfortable with that? Why I needed to do that so it looks like this. That tells me that p of x is the number -1 and that q of x equals x. So you notice that the questions have got simpler again, right? There's nothing really horrible about what we're doing right now, which is nice. So we've identified p and q. We're now going to calculate the integrating factor. Oh God, my brain is everywhere, but I got to get it out. Another saying, my dad said, what did he phrase it? Yeah. When he talks about something rare, he says, it's as rare as a one-legged nun walking a goat. What the heck did that mean? Have any of you ever seen a one-legged nun walking a goat?
Can't say I have, so it would be rare.
So it would be rare. So I guess it does make sense. The integral of -1 dx, e to the negative x. And again, would you agree that there is nothing miraculous or difficult going on here? Right. So we're into the solution. And I'm going to do the solution on this side here. So it's going to be 1 over e to the negative x, the integral of e to the negative x times this guy. We finally got our problem. I need to integrate that guy, right? What technique will I use to integrate that guy? Go for it.
That'd be a U sub.
Integration by parts.
I agree. I think someone else is about to beat you to it as well, right? That is an integration by parts question. What would this one in the bubble in the top right, what would that one be?
That would be a U sub.
Do you see the small difference can make to the technique? You see, just a little nuance like that can make a big difference. Right, this is the one we're being asked to do. I'll make this fella F, and I'll make this fella G. Then it's F, capital G, take away F dashed, capital G, dx. It is X. Right, if you integrate e to the negative x, you do get e to the negative x. Don't you also get a negative 1? So it's negative e to the negative x. A lot of negatives going to happen here. Take away, differentiate that guy, you get 1. Integrate e to the negative x, you get e to the negative x with another negative. So these get you negative x, e to the negative x. 2 negatives make this a plus. And then you integrate this one more time, and you get another negative. So we can take this fella and plug him in here. So far, so good, right? Oops, a little negative there, right? Let's do style points before we go hunting for C, because if we do style points, it'll actually make calculating C easier. Any ideas of a better way to write 1 over e to the negative x? One over e to the negative x, a better way of doing it.
E to the x.
Great. And now I am going to distribute through these 3. And something really cool is going to happen. E to the x times this, well, the minus x and the plus cancel out, so it's negative x. E to the x times this is negative 1. Okay, this isn't that nice, but would you agree that's much prettier looking than that? Would you agree the style points did its job? Now, very often, that's the end of the question. That is called a general solution to the differential equation. And that is normally the end, but not now. You are given this piece of information, which really says when x is 0, y is 8. And what that's going to allow us to do is to find out what number C is. And no, it's not always 8, although half the time it does end up being that. So y equals 8 equals x is nothing. So minus nothing, minus 1, plus c e to the 0. E to the 0 is 1, isn't it? Agreed? E to the power of 0 is 1. So what I get is negative 1 plus c. If you add 1 to both sides, you get c is 9. So we now have negative x, negative 1 plus c, 9, e to the x. And that's what we call the particular solution to differential equation. That is us finished. So do you see this little bit at the end, this last quarter? That's what makes this question different from what we did at the start of today, right? Because now we're going to find the plus c, whereas before we just stopped there. Does it seem pretty obvious, the process, what we need to do? Okay. We are doing good. I hope it's not just me zooming through and you're not sure what I'm doing, but we seem to be covering this pretty fast. It doesn't matter what you pick, there's going to be some weird stuff. Okay. 13 is the next weird one. dv by dt, take away 2tv, is going to equal 4t cubed e to the t squared. I'm not very happy about that. And the boundary condition is that guy. Well, the good news is it's good to go, right? I don't need to do anything. So I can tell you that P of t is negative 2t, and that Q of t is this ugly guy. You can now get the integrating factor. If you integrate this guy, you get negative t squared. And that's it. You can't make it look pretty. That's as good as it's ever going to be. So, oops, our solution is now going to be V equals 1 over IT, the integral of QT, IT, dt plus C. Basically, the T's are X's, vice versa. So it's going to be 1 over this ugly guy, the integral of 4t cubed e to the t squared times e to the negative t squared, and now I am happy. Can you see why I am happy? I thought we were going to have a really horrible question. What do they two guys make when you combine them? These two guys at the end that my fingers are pointing at.
1.
Yeah. So you are really looking at the integral of 4t cubed. Now, at the beginning, I was really worried about that because I know that this thing is going to have something to do with integrating. And I don't really like integrating things that are ugly because they take time. But look what it ended up being. Oh, and by the way, are you happy about the 1 over e to the negative t being e to the t squared? Now, if you integrate using the power rule, 4t cubed, you add 1 to the power and you divide by the new power. And I am looking at that guy and I'm saying, you are good to go. I don't think I need to worry about style points. Would you agree that's very nice? Looks good. So all I need to do now is find C. So when t is 0, v is 8. So 8 is equal to e to the 0, 0 to the 4 plus c. Here. 8 is 1 times c. Oh, that makes 8c. That was easy. So we now have our final answer. V is e to the t squared, t to the 4 plus 8. And that's why you use WebAssign questions. If I randomly picked an equation that looked like that, it wouldn't be very easy to make it come out so pretty. I would end up, if I randomly picked things, with some of the ugliest looking integrals in the world that would be really, really unrealistic to expect you to be able to solve. This is question 15. X squared y dashed plus 2xy equals log x. And the boundary condition is y1 equals 3. Divide everybody by x squared because this guy must be on his own. And if you do that, you get this guy. And you got this guy. Okay, you got 3 minutes. Go for it. Solve that one. I'll let you try it first. Is it? Okay, let's go for it. P of x is 2 over x, and q of x is that guy. The integrating factor is e to the integral of this guy, e to the 2 natural log of x. Actually, that's exactly the same thing that happened earlier today, isn't it? And so the integrating factor is really just x squared, which is really nice. So y will be this fella. So if you haven't finished, you can just kind of follow along. You get that guy. So I have 1 over x squared. The integral of x squared times that guy, which I'm really happy about. And now we have some cobwebs. We have actually done this guy before. In fact, I added them to this, where is it? This piece of paper, right, with all the standard integrals. You've got a better memory than I have. If you, well, actually, I know because I can see it now. If I didn't see it, I'd have to think hard. Does anyone know what the answer to that question, what that integral is?
X natural log of X
Yeah.
minus X.
X natural log of X, correct? And something else? I
Minus
didn't
X.
quite get minus X, right? Did you do that because you get a great memory, or you have a piece of paper with it written down like I have?
I had to do integration by parts. I don't remember.
Right, which is exactly what you'd have to do here. You'd have to call it 1 natural log of X dx. Make this your F and make this your G, and then do integration by parts. But the fact that you may have it, just to show you the guy I'm talking about. Where is he? I've lost the damn thing. Well, here it is. When you come across an integral that you think to yourself, oh, I think I might end up having to know that again. Because being asked to, an integral like log X on its own is a kind of possible question, right? Then if you find out what it is, you write it down. There's secant. That was a horrible one. Oh, there's one. Tangent. That's a horrible one as well. So we have got this guy, the X log X fella, and it's going to go in here. So it's 1 over X squared, X log X, take away X, add C. And I'm going to go for this version of still points. I'm going to distribute this. So it means I get log X over X, because one of the X's cancel. I get minus 1 over X, and I get C over X squared. Now, I wouldn't say that that's much better than that, but I think it just edges it in as being slightly prettier. And so now I'm going to use y of 1 equals 3 to figure out C, and we're finished. So X is 1, Y is 3. And did anybody get to the final part? Did you have enough time to finish it? Okay, good. Some of you did. So 3 goes here. The natural log of 1 over 1. Take away 1 over 1 plus C over 1 squared. Right. The natural log of 1 is actually 0. You can check it, but it is. Well, that's obviously negative 1, and that's plus C. So that makes C 4. And so your final answer is y equals the natural log of X over X minus 1 over X plus 4 over X squared. And stick a fork in it, and it's done. It's a good question, that, because basically, doesn't it use all the things that you need to do to solve a linear differential equation, including the last piece where you have to find out what the plus C is? So it's a very nice kind of all-encapsulating question. We are zooming. So where are we off to next? Let's do 18. Xy dashed is equal to y plus 6x squared sine x. And the boundary condition is that fellow. Couple of things I need to do here to get it to look like this fella. I need to get y dashed here. And don't I need to get the y next to the derivative, and it's over here and it should be on the left. I can do that in 2 steps. First thing, I'm going to divide everybody by x. Then going to subtract that fella from both sides. And it's only at this point do we start the process. If it doesn't look like this, don't start picking P's and Q's because it won't work, right? You won't get the right solution. The P of x is negative 1 over x. The Q of x is this fellow. The integrating factor is this guy, which is that. Yeah, it's not uncommon for these linear differential equations to have logs in them. Have you noticed that there's, I guess, about half the questions we've done, hasn't this ended up being some kind of log, right? So it's a pretty common thing to happen. But I still need to make it look pretty. And the answer is not x. It's not even negative x. It's a little bit, I don't know where that came from, it's an x. Do you see what I've done there is I've pulled in that negative like it's a number, which it is, it's -1, we just don't write the 1. And now it's appeared as a 1, because in this situation you need to write down the 1, right? So this and that are the same, which now means that the simplified version is that one. Are we happy about the integrating factor and why it's x to the -1? A multiple of a log is the log of a power. Right? I'm using the 3 log x gets you the log x kind of thing. Well, negative log x gets you the log of x to the -1. Let's that row. Okay, let's see what the solution looks like. This fella. This fella. Pretty standard. 1 over x to the -1. The integral of x to the -1 times 6x sine x plus c. Okay, let's fix this weird thing. 1 over x to the -1. There must be a better way of writing that, agreed? What does 1 over x to the -1 look like when you make it look simpler?
X.
Yeah. You don't even write the 1, isn't the convention? If you don't write it, it's there. Now, if you multiply this fella here by this fella here, don't the x's essentially cancel each other out? And we have got, almost like magic, an easy integral, right? We were worried that was going to be some, I don't know, integration by parts or u sub or some trig thing or whatever, and it didn't. It ended up just being that. And if you integrate 6 cosines, you get -6 cosines. And I would distribute. So there's your general solution. I'm now going to use y of pi equals 0. So when x is pi, the y is 0. So I get 0 here. I get a -6 pi cosine of pi plus c times pi. The cosine of pi. What number is the cosine of pi?
-1.
Agreed. I'm trying not to skip any lines here. Now remember, the goal here is to find C. It's a bit like solving an equation where C is the guy you're trying to find the solution to. Would you agree that the next step would be to subtract 6 pi from both sides? And then divide both sides by pi. So C ends up being the number -6. So the final answer is -6x cosine x minus 6, because C is a negative, x. Like in many things in mathematics, especially questions that are processes, like solving linear differential equations, the more practice that you get and the more little tricks of the trade, like how to make that turn into this, the more times you see it, the easier these questions will become. You can't really short circuit hard work. In other words, you just got to put in the time. If you do 200 U-sub questions, do you know you'll be twice as good when you'd only done 50? Right? You'll have seen a lot more different versions. You'll have noticed all the wee tweaks, all the special situations that aren't obvious. You'll even be good at recognizing when it's a U-sub question in the first place. So we are one last question, and we have finished with tons of time. So we have x squared plus 1 dy by dx plus 3 lots of x, y take away 1 equals 0. And y of 0 equals 5 is going to be my boundary condition. Okay, I guess the last one should be the ugliest or the weirdest ever. Any suggestions for what I should do next? Because it is definitely not ready. You know, it doesn't look like that. It's not ready to be turned into this. Not yet. Any suggestions about what we need to do? Well, let's look at the problems. Would you agree that x squared plus 1 has to go? Which is pretty common. We've seen that a lot. What we've not seen before is this. We've never had a question where this had happened. So the first thing I'm going to do is take care of the this. Now, it's a little bit closer to being this form. Let's see who we got. Would you agree that that negative 3x shouldn't be on the left? Shouldn't the x's be on the right? So I'm going to add 3x to both sides. Now we are getting much closer to being in this format. Let's try the question again. What should I do to both sides now to get this?
Divide both sides by x squared plus 1.
I agree. And I don't know if you need brackets, but I'll put brackets around that for emphasis. This is now in the correct format. derivative on its own, some function of x times y equals some other function of x on its own, right? Derivative on its own plus some function of xy equals some function of x on its own, right? You see, it's got all the features, which means that we can now identify, even although they are downright ugly, the P and the Q. You know, because this is the last one, it's not going to go smoothly, right? You know, they're going to throw everything but the house, you know, the farmer's house right on you, right? But I'm going to trust the math and let it take us to the end. We now get the integrating factor. Okay. A lot of the time this is easy, but not this time. I need to find this integral. Do you recognize it as a U sub? Right, that's the method. Yet another U sub. I'm sure we've probably done a couple of questions which are virtually the same as this, maybe by a number 3 and a 10, or, you know, a little minor difference. So the U sub in this case is x squared plus 1. You differentiate with respect to x, you get 2x. You do the crossover, and you isolate the dx. That's a pretty standard U sub question. So what do we get? We get the integral of 3x over u times 1 over 2x du. That gets us, the x's cancel, 3 over 2, that guy. Which gets us 3 over 2 log u, which gets us 3 over 2, the natural log of x squared plus 1. So we have now got this integral, it's that guy. So it's e to the 3 over 2, the natural log of x squared plus 1. And we think style points. And yeah, there is a log there, and yes, there's an e there. But isn't there also a 3 upon 2 in the way? And I think this is the third, if not fourth time today we've had to deal with this kind of similar situation. Won't that 3 halves come inside as a power? Right. 2 log x gets you log x squared, essentially the same rule. These are inverses of each other, so whatever is left is a simplified version. There is the integrating factor. So we made it so it was in the right format. We found P and Q. We've now found the integrating factor. Things are slowly moving along. The solution is, the general solution is coming up now, which is that guy. 1 over x squared plus 1 to the 3 halves. I don't like the looks of that. X squared plus 1 to the 3 halves. Q of x is this guy, 3 times x squared plus 1 dx adds c. There's nothing nice about that. I'm not even going to attempt to do anything good to right now. I'll just leave it like that. Let's just focus on this. this is x squared plus 1 to the 3 halves, and this is x squared plus 1 in the bottom. Can't we cancel these at least partially? Right, x squared plus 1 on the top, x squared plus 1 something on the bottom. This is essentially 1, and this is 3 halves. So top, take away the bottom. Are we okay with that guy? Are you happy with where that guy came from? And there's an X somewhere. Right. Now you happy what we have now?
Did we lose an X on the Q?
Yeah, I put it back. It's here.
Okay.
Now.
Yeah, it is.
It's there and I just missed it as a transfer. So we are in for some fun because we have to do this guy. No clues. Come on. Last question. Last question essentially from Calc 2 from me. What method will we use to integrate that ugly bugger?
U sub.
Good. Might have been a guess, but I'll take it because it's right. And who is the U sub?
X squared plus 1.
Because it's really the only decent U sub in town, right? Differentiate with respect to X is 2X. Did you get that, Ryan, or was it just your brain told you again?
Well, I see that the X will cancel again.
Right, so you got a little insight into why that was a good choice. That's good when you can see that. So we have got 3x u to the half, 1 over 2x du, 3 halves u to the half du. And we can integrate using the power rule. Add 1 to the power and divide by the new power. Oh, is that not cool? Don't they cancel out and you're just left with that? Which is x squared plus 1 to the 3 halves. It's almost like magic, isn't it? The way these things just kind of plop out like this. So what do we have? Well, the general solution right now is this fella. We just found this guy. And what I'm going to do is I'm going to distribute it. And this times this gets you 1 over x squared plus 1 to the 3 halves. I think I can leave that. I could make that a square root, but it's pretty nice and great. Could have been a lot worse. So let's finish. Let's find C. When x is 0, y is 5. So plug a 5 in here, and you get 1 plus. When x is 0, can I just do a whole load in my head? Isn't 0 squared plus 1, 1, and isn't 1 to the power of 3 halves still 1, and isn't c over 1 just c? Can I just do that, and it's hopefully obvious? That when plug 0 in here, you just get c. And that makes c 4. So we don't have drum rolls or anything really, but the last homework question, at least from this section, we are done.